This video will demonstrate the internal rate of return crossover problem using Excel. So one example of the crossover problem is demonstrated here. So suppose today you pay for a project that costs $100. A year from now you receive $180, and 7 years from now you have to pay back $100. So you can think of this like leasing or a machine or something to that effect. Well, because the cash flow changes signs more than once, we have the possibility of multiple internal rate of returns. So here we have the internal rate of return formula using Excel. And the second optional argument here is guessing, which automatically guesses 10%, but I changed it here to get it to where it would change to the lower IRR 4.88%, and then here a different guess yields 76.72%. Well, how can we get the guesses or see what the IRRs are? One thing you could do is you could put in your various guesses and calculate NPVs to draw the NPV profile, as demonstrated here, where you can see that at 4%, and indeed again at 80 or so percent, or excuse me, 76.72%. we said that it crosses over at 0. So then one question becomes, which of these rates do you use? And honestly, the best thing you should do is whichever of these rates is closer to your hurdle rate, or best case scenario, actually using net present value to help you make your decision rules. But you do have somewhat of an ethical dilemma here, stating, you really want the project to go, you probably would tell your superior the higher one versus the lower one, but is that truly ethical? Probably not, because there are indeed two IRRs. And then obviously from a conservative perspective, you'd pick the lower one. Aggressively, you would pick the higher one. So that's one example. Got here several other examples. So this is another one, kind of similar, except with this one, what's interesting is you have a negative internal rate of return, which goes into all sorts of other questions. What does that even mean? Because ultimately, you're just trying to solve the function where net present value is 0, and you wind up getting two answers here. This one's also a similar one. I'll just zoom in and show you this one real quick. But what's fascinating that I've been looking at too is, when can you get Excel to cross over to you a different rate based on different guesses? So for example, in this one, the answers were negative 63 and 17% respectively. You can see that the different guesses in this particular range, fascinatingly, change over multiple times until it settles in at 17%. So even sometimes there may be one particular crossover rate, like with the local maximum. Other times it kind of just swings and varies and then settles into a steady guess that doesn't change. This one is another example of two positive IRRs similar to the first example. And this one, once it swaps, its head has swapped completely. And to determine what that rate is, or what the maximum NPV is, you can use the solver function. So data, if you haven't got solver into your Excel, you can do that by going to File, Options, Add-ins, Go, and then check Solver Add-in. So for this one, you can use a solver function, and what I'm doing here is I'm setting the maximum of the NPV using the NPV function. For this here, trying to maximize it by changing the rate by which we discount it by. And you said in this case it is indeed that 27% gets you the max NPV of $368,000, as demonstrated there. So here's a couple other examples. These have triple-digit internal rate of returns. And then this one obviously is indeed not correct. You can resolve for this. So here 140% looks to be the max, but it crosses at 100 and 200%. but before the 100%, it's negative. So probably would never accept this project since the cash flows don't even sum up at a zero in a world with no interest rates to a positive number. So that may not be a good project unless you have to do it for like cost reduction or other purposes. Sometimes you can get no IRR. And here's an example of that here, where you pay 100 today, you receive 100 today, pay 300 next year, and then get 250 back in 2 years. So if I were to try to maximize this, let's see if we can do that. So here at the 0%, we get a max of 50, but let's say this particular graph may not be showing that. So I can edit that real quick to show you. And notice that no matter what IRR you put in, you never get an answer there. There is no IRR. So there's that for you. And that's interesting because it maximizes there. That's probably a local. But if I change that to say negative 99%, so you get a bigger answer there. So that's interesting result. Probably because my solver settings may not have included negative numbers. Yeah. If I did this, there we go. And then the last one here, this is another example. Kind of going back, and this is again another 100%, 200%, but you can see here you have 1, 2, and then 3 again. Actually, this one's got 3 IRRs because the signs on the cash flow change 1, 2, 3 times from negative to positive to negative to positive again. So pay 1, receive 6 in year 1, pay 11 in year 2, and then receive 6 again in year 3. So some of the cash flows is 0. So in a 0% world, would be indifferent about accepting the project, but we got 3 different IRRs going on here as demonstrated by this graph. So thank you for watching. Here's some citations here. Paper by Hirschleifer in the 50s, CFA Institute, and then Kevin Bracker, Pitt State, with their Text Business Finance Essentials. So thanks again for watching, and be sure to like and subscribe below to get new content weekly concerning financial literacy, financial education, and using Excel. Thank you.